Hello guys, welcome back to our channel again. Today we will discuss a very good question of CodeChef, which is who fires brackets. Now, what we have to do in the question is we have given a set of n brackets. It can be opening, it can be closing. Now, at some point of time, chef will be standing in front of tth or the ith bracket, and then he have to find such a sequence in which he can find a balanced bucket sequence. Now, what is a balanced bucket sequence? We have to find out first that thing, then we have to find one more thing, that what we have to do it properly in the question. Now, suppose this is our sequence: opening bracket, opening bracket, opening bracket, then closing, and then closing. Now, suppose chef is standing in front of this at the point 4. So, the initial position of the chef will be given in the question. In this case, suppose it is 4. Now, on 4, we are just checking that it is opening bracket or closing bracket. So in this case, it is the opening bracket. Now we will traverse the next. So it is closing. So we have got a balanced sequence, an opening bracket and a closing bracket. So this is a sequence which is known as balanced sequence. So we have to find for every sequence or from every position that we can obtain this balanced sequence or not. In this case, we cannot ignore the opening brackets, but we can ignore the closing brackets. Suppose we have this as a string and we are starting from this one. Now we can ignore this, we can ignore this, we can take this, we can take this. So we'll get our answer. In this case, we cannot ignore this. If we start from 1, we cannot ignore this, we cannot ignore this, we cannot ignore this, we cannot ignore. And we have to take all 4. So in this case, our answer will not be there because 3 closing brackets are there, whereas 4 opening brackets are there. So if we start from 1, our answer will be -1. So this is the question. What we have to mainly do, we have to find the non-empty balanced bucket sequence from every position of the string or every position from the bucket sequence. In this case, first of all, we'll not consider these 2 queries. We'll directly find for every query, for each index we will find, and then whenever the query will come, we'll directly put out the value which we want to put out. So this is the question. Now we will discuss our solution, that what will be our approach. At the end, we will submit our solution. So now, for proper understanding of the question or proper understanding of the approach, we will take this as an example. Now, till now, we have observed one thing, that closing bracket can be ignored, but opening bracket cannot be. So, for finding a non-empty subsequence, we must have one or more than one opening sequence. So, first of all, we will try to find an opening bracket. Then, we will alternately find the closing brackets. Now, in this case, what we are trying to do, suppose if we find the first opening bracket. So, in this question, we will use a stack. So, whenever we will find an opening bracket, we will push back that value into a stack. So, our stack will initially be empty, and whenever a value will come, then that value will be initialized in the stack. So, initially 0 will be initialized when we will come on first. Now whenever our whenever our closing bracket will be there, then we'll push back the last value from the stack, which is the top. Now 1 will be there. Suppose in this case 0 will be there. Now whenever we will come on 1, so closing bracket will be there, so we'll push back this 0. So after the iteration, the 0 will be brought back, or nothing will be remaining in the stack. Now again the same thing will come. This 2 will be pushed back, then 3 will be pushed back, then 4 will be pushed back, then 5 will be pushed back. Now our closing bracket will come, then 5 will be pop back, then again the closing bracket will become, then 4 will be pop back, then 3 will be again pop back, then again closing bracket will be encountering, so the opening bracket will be there, so again we'll push back that value. So whenever the opening bracket will come, we'll push back that value into stack, and then whenever the closing bracket will come, then we will pop it back. Now why we are trying to do this thing, I'll explain you that thing. Suppose you have find this sequence. I have not written 5, so I should written 5 also. So currently we have started iterating from this. So 5, we are on current 5. Now whenever we will encounter a closing sequence, then we all know that these 5's value will contain a optimum or a balanced subsequence of brackets whenever the value will start from 5. So this closing bracket will encounter this 5, so this closing will be satisfied, or this closing will be done easily. So 5 is there, so 5 plus 1, 6. So this value will be completed when 6 will be there. So 6 will be there. Simply for 4 also, the next value, which is 7. So here 7 will be completing this. So at next index 8 will be completing this. So like this, whenever we'll get 5 as an input, our answer will be 6, because at 6th index it is completed. For 4 it is 7, for 3 it is 8. So first of all we have to count the opening brackets, then whenever the value of closing brackets we will encounter, we'll push back the last bracket, last opening bracket, such that we can get our value. Now you might confuse in all these things, so for removing your confusion or for solving your confusion, I'll just take a help of a simple code, or with the help of code I'll explain, that will make your mind to easy understand that what is going on in this question. So till now we have understand one thing, that we have to find the opening brackets, and whenever the closing brackets will come, we have to return an answer from particular index. So for that we require two things. First of all, the stack, such that whenever the opening brackets will come, then we will push back that value into the stack, and a vector integer which will store the answers of every index. Now this loop will iterate over all the values of this string, or all the values of this bracket sequence. Now this will start from 0. So first of all, one main thing you have observed here is this -2. Why I am using this -2? Now our answer will be stored in the form of indexes, and we have to return our answer in the form of position. So we have to add 1, and if we does not found our sequence, we have to return -1. Now if I take here -1, then after adding we'll get 0. So for avoiding that thing, our answer should be -1. So for avoiding that thing, we are using -2. So this is the simple reason why I am using -2. Now initially stack will be empty, so we'll take a stack as empty. V1's all the values will be initialized by -2. So all the values will be initialized by -2. So vector will be initially looking like this something. So we'll not go more into the vectors part, that how next values will be iterated. So first of all we will start iterating from I equals to 0. So at I equals to 0, opening bracket is there, so we'll push back that value into the stack. So our new stack will store one value, which is 0, the index, mean index. Now nothing will be anything other than this, nothing will be happen. If opening bracket is there, we'll directly push back that value into SP. Now At I equals to 1, we does not found an opening bracket, so we will go into the else part. Now in else we have to check one condition, that the size of this st is greater than 0 or not. So in this case it is 1. So we'll go more into this part. Now our this v1, here the next is v1 only, there is some typing mistake, so here v1 will be there. So v1 stop, so this top will be checked that what is there, so this 0 will be updated by I, so here 1 will become. Now what this is doing, this whenever we'll start from 0, our value will be completed at 1. So this thing is done by this loop. Now this value will be popped back, so it will be again empty. Now I will be equals to 2, again closing comes, here the value will be pushed back, then 3 comes, then this will be pushed back, then what comes, 4 comes, then 4 will again be pushed back, then 5 comes, then 5 will again be pushed back, first 4 and then 5. Now 6 comes. Now at 6th index we have a closing bracket. Again this thing will be iterated, top will be pushed back, the 5, so 4th index, first, second, third, so 5th index will be updated by 6. Now again 5 will be popped back, or sorry popped. Now 7 will come. Now again we will check the stack, so 4 will be pushed back, and that place will get 7. At this place we'll get 9, sorry 8. Now 3 will be pushed back, and now our iterator will be on 9. So at 9 we'll found one more opening bracket, so we'll push back 9. Then on 10 we found the closing bracket, so here's 7, 6, 7, 8, 9, and on 9, so on 9 we'll push back a value 10. Then again the same thing will happen. On this also we have to push back the value 11. The same thing will be happening again and again, and till now we will get a sequence of such 2's, minus 2's and digits. The minus 2 will represent that at that index we does not found any opening and closing bracket sequence. Now till now one problem will be there. Suppose we have a sequence like this. We have a sequence, there's opening bracket, opening, so this closing brackets, then opening, then closing. So in this case our answer for all these opening brackets, so all these closing brackets will be minus 2. Now it should not be there. What it should be there? It should be the last index for every value till here. So this thing we will do with the help of one more loop which we will use. Now this thing is an important thing. You must not observe this thing, that whenever the closing bracket will be there, we can ignore that. So if this is not there also, then also it doesn't matter. It matters whenever the opening bracket is there in front of it. Now whenever a closing bracket comes, now we'll check that its previous value, if this value encounters this value encounter, then we'll check its next value. What its value? We'll push back the same value here also, same value here also, so till end we will push back the same values. So one more thing we have observed, that whenever the closing bracket will be there, then we have to push back the values, or we have to copy the previous values of the indexes. So these two things only we have to do, and whenever a query will come, we will directly return the index of this v1. So now we will look at our code, that what we have done in the code, and then we will return our. So this is the main code which we are trying to do. So first of all, here I have taken some inputs, the AS and Qs, and the queries which we all try to solve, and then we have called this solve. So one main thing which you observe in this question, that I have get the global variable such that I does not require to pass that values through this solve function. So this is not my solution, this is the official solution we will get from the CodeChef. So that's why we are using this solution, so that we'll get our optimum solution. So first of all, we have calculating the size of the string, then the stack we have initialized, then the vector we have initialized. The same thing till now, till here, and till line number 25, we have discussed everything. Now next thing, which the closing bracket thing will be done by this loop, this n minus 2, I should be greater than 0, I plus plus, sorry, I minus minus, and then we will check that values. If any value is a closing bracket, then we will check, or we will push the same value which we have for previous, or which we have for the next index of nxt or v1, whichever we will take. And at the end we will run for the q queries, and we will check the values, we'll add it one, and then we will submit. So if I submit the solution now, so we got correct answer. So this is the solution for the third question of coders league. So this is the question, not tough question, but a tricky question in which if you know the stack, you can easily implement